Okay, you guys aren't going to be fans of what I'm about to tell you, but haters going to hate. You got two tests. The next test we take, you'll be taking two of them. This one you've already taken once, and this is your first go around on standard 4. There's 6 standards in the semester. Standard 5 is the hardest one. Okay, that's what we're about to get to next. It's just got a lot of info. Okay, you're doing patterns of linear functions. You need to write a rule for the function in this table right here. This standard doesn't take a long time, but you need to kind of know what it is you are supposed to be accomplishing on each problem. Writing a rule for a function is writing an equation. So I can see the number of photos. We got 0, 1, 2, 3, and then the memory in the bank is 512, 509, 506, 503. Now, this is the domain, this is the range, okay? And you already know what they are, okay? So you start with your range variable, which is m, and that starts at 512. Then as you can see, you're decreasing, so subtract, and what are you decreasing by every time you go through that table? 512, 509, 506, 503, you're decreasing by 3. Okay, now you're doing it every time there's a photo, so P is your independent variable. And pay attention to what your domain is increasing by. It's just 1, so 3 divided by 1 would just be 3. Okay, if it's any other number, we got to leave it there, but just a 1. And there you go, M equals 512 minus 3P. Now, the next one, you look at a function, you got to tell if the relationship's linear or nonlinear. Okay, so this is your domain, this is your range. Your domain goes in a pattern, but does your range? Well, not really, because that goes up 3, that goes up 12, that goes up, it actually goes up by 48, okay? I'm not seeing a pattern there, at least a linear pattern, so therefore the function is non-linear. Okay, now here, -1 to 2. Now think of a number line. If you're at -1, you end up at 2. That's a change of 3 units. And then 3, 3. So that one definitely is linear. I definitely see the pattern. Okay, next one. The graph is optional. Only use it if it helps you. Okay, I want you to do me a favor. Can you please change that $35 to a $36, please? It says peanuts cost $6 per pound. You have $36 to spend. What's the domain and range of the situation? Then is it continuous or discrete? Well, to figure out your domain and range, I'm going to set up a table. And you got your domain here, your range here. Now, money is always the range. You got pounds and money. Money needs to be the range, and then the domain is how many pounds we buy. So if I buy 0 pounds, I'm not going to have to pay any money. If I buy 1 pound, that's $6. If I buy 2 pounds, that's going to be $12. 3 pounds is $18. Now that's enough of that. Now find where you stop at. You stop at $36. And then to find how many pounds correlate to that, you simply take your $36 divided by 6. Well, 36 divided by 6 is 6, so this would be for buying 6 pounds. So that's not that hard. So the domain's 0 to 6, and the range is 0 to 36. Now, the always interesting thing is the domain and range. What's a graph, continuous or discrete? Okay. Now, there's a couple ways you can look at that. I'm going to go between one of these numbers and just put a 0.5. I'm going to put 2.5 question mark. Now, it's pounds. If you're weighing something, they can be decimals, okay? So even the decimals in between the whole numbers make sense, so therefore it's continuous. And by the way, continuous graph, remember the graph is optional. You can just watch this if you don't really think you'll need it. 0, 1, 2, 3, 4, 5, 6. So zeros was 0, 1 is 6, 2 is 12, 3 is 18, 4 is 24, 5 is 30, 6 is 36. Now, this would not be continuous. I would not connect these points because connecting the points means like, and I would, oh, sorry, my bad. I would connect the points, okay, because it's continuous, because you would connect them because even between the whole numbers, it could happen. Like 3.5 is possible, 4.5, it's pounds when you weigh something. Weights don't have to be exact. Okay, graph the function using a table. So again, there's two ways to do this. On a test, I would recommend, even if you, look, there's just one of these, so it's not like it's going to take you all day. So if you want to do it the long way, because you think that's your best chance of getting it right, do the long way. Okay, so we got y equals 4 times x minus 5. So to find the y, we replace the x's with -2. So 4 times -2 minus 5. 4 times -1 minus 5. 4 times 0 minus 5. 4 times 1 minus 5. And 4 times 2 minus 5. 4 times -2 is -8. If I subtract 5, that's -13. Think a number line. 4 times -1 is -4. If you subtract 5 from -4, you're going to end up at -9. That's 0. 0 minus 5 is -5. You can see the pattern developing. 4 times 1 is 4. 4 minus 5 is -1. 4 times 2 is 8. 8 minus 5 is 3. Okay. Now, that's a long way. The short way would be, I got to make a smaller table because this is a different problem. But only use a short way if you think you'll remember it. So if x is 0, the number not multiplied by x is your y. Then it's called the slope. The multiplier of the x is 4. Okay, so this is going to go up by 4 because it's positive. So if I go -5, and by the way, if you're thinking number line, you go this way 4. So if you're at -5, you go 4 to the right, because 4 is positive, you'd be -1. 4 to the right from there is 3. And then if you look at your pattern, this would be -9, -13. That way you got to have down cold, though. Okay, so -2, -13. I go backwards 2 and then down 1, 2, 3, 4, 5, 6, 7, 8, 9. Just put it out there somewhere. Okay. -1, -9. I go left 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9. And actually, you can count by 2s, but don't do that yet. Okay. 0, -5. I go down 1, 2, 3, 4, 5. Don't move forward or backwards if the x is 0. Remember, this is x, this is y. Forward 1, down 1. Forward 2, up 3 now, because 3 is positive. For the first time, you got a positive. Okay, now the points definitely go on a line. I would just ignore that point that's off the graph if I were you, and I'd just line up the ones that are there. Okay. There's a line. That's a pattern for it. I gotta set the camera here. Otherwise I can't manipulate my ruler. Remember to put arrows on each end because the graph is continuous. Anytime it's just an equation, it's continuous because you can put decimals in for x. Okay, tell her the coordinates represent a function. This is the vertical line test. It's got to be vertical. It can't be this way. Is there anywhere on this graph you can make a vertical line and cover more than one point? No, 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 no. Boom, right there. Well, that means it's not a function, okay? Because that has repeated x values in the domain. So not a function. It only can cross once. Crosses 3 times there. Okay, next one. Vertical line there would just be 1 point. Right there would be 1. Just go through 1 here, here, here. Okay, that is a function because I would only be able to cover 1 point. Okay, number 8, identify the domain and range of the relationship. Then tell whether the relationship represents a function. So again, x, y, x, y, x, y, x, y. I want to see what the domain and range are, so I know you're not just guessing. The domain is 0. If you just write function or not a function on this without telling me what the domain range are, that's going to be points off. So domain, you got 0, 3, 3, 5. The range is the y, 2, 1, -1, 3. Now I focus on the domain and there's a repeat value, so it's not a function. Because if I made these points, I would be able to draw a vertical line through that point and this point and this point. Okay, next one, -4, -4. Domain, you got -4, -1, 0, and 3. Range, you got -4, -4, -4, -4. Now, I'm going to get some suckers on this one. Again, I've said it multiple times. You just pay attention to the domain. I know the range has numbers that repeat themselves, but the domain does not. So therefore, that makes it a function. So don't take the bait on the range. Okay, the height h of a helicopter is 40 feet above the ground. The height of the helicopter increases at a rate of 21 feet per second. S, write a function rule. Okay, so you got height, that's your dependent variable, equals 40. Increasing by 21, but because it increases 21 multiple times every second, we put an S variable because it would be multiplied by the number of seconds. Okay, and that's a wrap on that. Not a lot of stuff, but just you got to remember what it's asking for. Okay, now this one we've taken one time before. You're basically on the whole thing. Your job is to solve for x. Okay, now how many times does x appear in this equation? Once. I would put a 1 in front, dot it, and circle it. Outside the 1 times x, you got -4. You need to add 4. -12 plus 4 is -8. Okay, and then if you want to divide by 1, do it, but it's still -8. That's why a lot of times you don't see the 1 there, but it does help people when solving. Okay, next one. X appears once. I'm going to dot it, circle it. Now, I don't need to add or subtract. Okay, I go straight into the division by -5. -125 divided by -5 is 25. I have a lot of people that just freak out when they get to a problem like that. Dot it, circle it, and you'll see, gee, there's nothing to add or subtract, so I divide. Okay, next one. 16 minus 3x equals 34. Okay, so again, dot your x right there. Circle it. Include the minus in your circle. Now, outside, you got 16. You got to take that 16 to 0. You would subtract 16 to make it 0, and then subtract it from 34. So I have -3 times x equals 18 is what that is. Now I divide by -3. 18 divided by -3 is -6. Okay, next one, number 4. You got to get rid of the parentheses first. Again, you have to get rid of that. So look in your parentheses and the number outside. Now, we're going to put a 1 there. These 3 numbers, if they have minuses, they're plus negatives. And I'm going to simply distribute that. Okay, here's what I'm just simplifying right here. So I could take -3, -3, and we're going to multiply it by the 1x and then by the -2. So it's going to be -3x and +6. So here's my equals. 16's the lone wolf. And then we write -3x plus 6. Now that's done, but I got to remember there's an x there, so plus x. So that is what you do the second you see a parentheses. Now, how many x's are in that equation? You have 2 of them, so don't do the dot in the circle, okay? you got to pay attention if they're on the same side or the equals, or if they're on opposite sides. Those are clearly on the same side, so we put a 1 in front, and then we connect them with the v. So I take -3 plus 1, and that's -2x. Now remember, plus your 6, and then equals 16. Okay, now that x only appears once, you can do the dot, you can do the circle, you can go from there. So you're going to subtract 6, subtract 6. 16 minus 6 is 10. So you have -2 times x equals 10. Now you're ready to divide by -2. So 10 divided by -2 is -5. In the second you see parentheses, you have to do the rainbows. Okay, number 5, we got x minus 1 plus 5x equals 23. Now, there are no parentheses, so that's good. But x appears twice. Here's the equals. They appear on the same side, so I do my v. So that's a 1 and a positive 5. That's easy. 1 plus 5 is 6. 6x minus 1 equals 23. Now that x appears 1, I'm going to put a multiplication dot and circle it. You got a minus 1, so you're going to plus 1. That's 24. Divide by 6, divide by 6. 24 divided by 6 is 4. Okay, next one, I see parentheses, 2 sets of parentheses. So again, you got the parentheses here with the multiplier of 7. You got a parentheses here with the multiplier of 5. Now, there's nothing to worry about outside of that, so 7 times -2x, 7 times 6. Well, that's going to give me a -14x and a 42. So I come over here and I write that as -14x plus 22, or 42. And over here, you got to take 5 times -3x, and you will be taking 5 times 1. So that's -15x plus 5. Now, how many x's appear? 2 of them, but they're on opposite sides, so we're not making the v like we did up here. We got to take the smaller one right there and take that to 0. How would you take a -15 to 0? Well, you'd add 15x. Then I go add it to 14x. So that's 1x plus 42 equals 5. Now I got a multiplier of 1, but first, before I worry about that, I got a minus 42. So 5 minus 42 is -37. So we have 1 times x equals -37. Divide by 1, and that's -37. Okay, now solving for x. Oh, another double shot of parentheses. That's all you got on that side. So again, I don't have to worry about anything outside like I did on this one, where I still had something outside I had to put. 2 times 2x is 4x. 2 times 5 is 10. Now over here, taking 4 times 1x is 4x. 4 times 2.5 is actually 10. Now, x appears twice in the equation. We have to simplify it so it only appears once. This time, again, they're on opposite sides, so I would want to take the smaller one to 0. Well, the problem with that is there isn't a smaller one because both the x's are the same. So you get rid of them. Now, if somebody comes up to you and says 10 is equal to 10, you'd say, well, no, duh. Okay, so that means x equals any solution. Okay, now let's look at the next one. Does x appear more than once? You don't have to distribute here, but x does appear 3 times. So I combine the 2 on this side together. That's 7x minus 3 equals 7x minus 10. Now they're on opposite sides. So now I pick the smaller one again, but the same thing happens as up here. We don't have a smaller one. So the x's go away. And what if somebody came up to you and said, -3 equals -10? You'd say you're an idiot, right? So x is no solution. Okay. Okay, number 10. The fraction just freaks people out. Don't let it, okay? Dot your x and circle it, and you got a -6. You're going to +6, +6. -9 plus 6 would be -3. I'm going to do the same thing I always do when there's a dot. Divide, and I will be dividing by the -1/3. There's no law saying you can't divide by a fraction. I know it looks weird, but it gets the job done. I got 9, okay? There is a quick way to do that in your head. You could divide -3 by -1, which is 3, and then times 3 is 9, okay? But that is a hard trick to remember. Okay, now the last one, you're not going to put a dot because your x is underlined. If the x is underlined, don't put a dot. You're going to circle the line. So outside of that, before you deal with the 2, you got a +3. You got to take to 0. So we got x divided by 2. -15 minus 3 is -18. Now, when I see division in the equation, I just multiply. Okay, 2 times -18 is -36. I'm just showing you what I'm doing. Okay, number 12. Now, the table up here, I want you to look at this. We're going to read it, then we're going to look up that table. You are not going to use the proportions. Proportions, when you make those lines, when you go this equals that. You can't do that on this. There are 1,200 people in a town. The population will increase at a rate of 150 people per year. In how many years will there be 2,100 people? Now, you're going to make the line because at year 0, you already have 1,200 people, so they don't both start at 0. So you make the line and you use this strategy. So your units are people. I'm just trying to help you not get it confused with some of the others that we've done. Remember, the time unit's the x, and then the other unit's the people, or the y is the other unit. So per year, and put people per year, please. The rate of increase is by 150, so it's 150x, because x is years. So we put 150x at the beginning of the line. Okay, now before we look up there, there's 1,200. That's why the line is used, okay? Because if it's 0, 0, the line's stupid, because I'm not going to have anything at the beginning. Equals y. So that's my equation. 1,200 plus 150x equals y. Okay, now I need to take that last value, 2,100, and you got to pay attention to the label. It says it's people. Look at your first box. People equals y. So we put that in for y, and we solve for the years, the x. So 1,200 plus 150x equals 2,100. Okay, you don't have any parentheses. X appears once. Dot it, circle it. Get rid of the number outside by subtracting it, taking it to 0. 2,100 minus 1,200 is 900. Oh, it's 900. No, it's just 900. Okay, then I'm ready to divide by 150. So 900 divided by 150 equals 6. Last one. Okay, I am comparing the cost of two golf courses. Membership at one course costs $100, and there is a fee of $5 per round played. Membership at the second course costs $250, and there's a fee of $2 per round played. How many rounds of golf will the total cost for the two courses be exactly the same? Now look up here, you got rounds and dollars. Obviously, you have 100 before you have to play golf. You have rounds. Same thing over here. So that tells me we're going to need lines. You're actually going to need two of them here, like that. So you got money and rounds. Well, money cannot be X, okay? X is time, but if you don't have time, you cannot have X be the money. Y has to be the money. X is the rounds. So what's the rate of change? Dollars per round. Well, I got $5 per round. And the other one's $2 per round. 5X, 2X. Don't add those together. They're separate. That's why you see two separate tables. So you got 5X, 2X. Plus equals Y equals Y. Now before, with the $5 per round, this guy paid $100. Okay, so it's 100 plus 5X. And then this one has $250. Now our job is to match the lines up. Okay, so I ignore the Y's. I don't care. Okay, so on the first line I have 100 plus 5X. And I want to know when that's equal to 250 plus 2X. Okay, now you don't have parentheses, but the X appears twice in the equation. And it's on opposite sides, so we mark the smaller one, take it to 0. So minus 2X, then subtract it from your 5X. 5X minus 2X is 3X. I'd put that first, then I'd put plus 100 equals 250. Okay, here's the only X. It's multiplied by 3, but before I divide, I have to subtract 100. 250 minus 100 is 150. Then divide by 3, divide by 3. 150 divided by 3 is 50. So X equals 50. They'll be equal after 50 rounds. Again, you can always check your answers. You can take 100 plus 5 times. It's X, but I think X is 50. Okay, so that's 350. Then the other one, I can take 250 plus 2 times X, but I think X is 50. 350. Since they're equal, I probably did it right.